we're going to continue, and now we're going to work on writing the equation of a line. So we already know about slope and its rise over run. To get the equation of a line, there are several different paths that you can take. The first path we're going to talk about is when you're given a slope and a y-intercept. From earlier, we find the slope of a line by looking at the number in front of x when it is solved for y. What we didn't mention is whatever is being added or subtracted to that x is the y-intercept. So if you have a line with a slope of 4 and a y-intercept of 8, the equation of that line is y equals 4x plus 8. And that's proven, and we call this slope-intercept form, and in the formula form, it's y equals mx plus b. Now, this is something that's good to write down on your formula sheet so that you have it in front of you as you work through the lab. Let's practice. Let's write an equation of a line with a slope of 2 and a y-intercept of 0, -3. So I'm going to take away from that my m is 2 and my b, my y-intercept, is -3. So I'm going to plug that into slope-intercept form to get the equation y equals 2x minus 3, and I'm done. This method is one of the quickest methods to getting the equation of a line. Now, let's graph that line using the exact same information. If I want to graph it using the slope and the y-intercept, the first thing I need to do is put it into slope-intercept form by solving for y. So here, I would subtract x from both sides, and then I would divide by 2. This gives me a -1/2 for my slope and a y-intercept of -2. So I would select the graphing tool in my math lab, and I would plot that y-intercept of -2. Now, a slope of -1/2 means that I go down 1, right 2. So I'm going to move that direction, put my new point, and the lab will connect the dots, and then you have your graph. Let's look at writing the equation of a line when we have the slope and a point on the line. That's going to be a little bit different. When I have a slope and a point on the line, I have to use a different equation called point slope, assuming the point that I'm given is not the y-intercept. To write the equation of a line with a slope of 2/5 that passes through the point 3, -4, I have to use the point slope form, which means I need to know the slope and I need to know the point. Now, the x and the y that are in black are numbers that you do not replace with the point. The red and the green x and y are replaced with the number from the point. So once I replace those values, I can take that equation and solve it for y, and then I have a graphable equation. You're going to want to read the directions. Sometimes they won't ask you to put it in slope-intercept form, but if the directions did say put it in slope-intercept form, I would need to do that. Here's the second method. I could take and I could plug in the point, 3, -4, this is an alternate way, and plug in the slope, and I could solve for the b value and then put that in slope-intercept. I don't really find that to be a faster way, but some people do, so I wanted to make sure I showed it. Now, how will we write the equation of a line if we're given 2 points that are on the line? Well, the logical answer that you probably thought of is, well, I need a slope. So we're going to use those two points to find the slope because every equation of a line needs a slope. Once I have that slope, I can use either point and plug it into that point slope equation where I replace x and y with values from the point. Now it wants the equation in general or standard form, which means I need my x and my y on the left-hand side. So I'm going to take that, and to get it on the left-hand side, adding 2/3 x is not very pretty. So what we did was we multiplied every term by 3 to get the least common denominator so that we could then get rid of those fractions and bring x and y over. You cannot have a fractional coefficient in standard form. You have to multiply, and you can go back to chapter 1 videos and look at how to multiply by that least common denominator to get rid of it. Now we're going to look at equations of horizontal and vertical lines. Those lines are y equals a number and x equals a number. So if I want to write the equation of a line passing through the point 2, -1 that has an undefined slope, I have to remember that's a vertical line. The equation of a vertical line is x equals some number. So the equation of this vertical line is simply x equals 2, the 2 coming from the value within the point. If I want to find the equation of a line that's at 2, -1 that has a slope of 0, that's a horizontal line, which is y equals some number, and I'm going to take that -1 from the parentheses. So if I want to write the equation of a parallel or perpendicular line, I'm going to use the information from the previous section. So now we're moving away from just writing the equation of any line to writing some very specific lines that are going to be parallel or perpendicular. So if I want to write the equation of a line passing through the point -8, 3 that satisfies the given condition, I want to first find the slope of this line. So I'm going to do that by solving for y. Once I've solved for y, then I'm able to know that I have the same slope because parallel lines have the same slope. And I'm simply going to plug point slope in with the point on the parallel line. So I'm replacing the 2/3 and I'm getting that -8 and 3 and plugging them in. And if I want it in slope intercept, it just has to be solved for y. Now, if I want the perpendicular line, I'm going to follow the same process, but the slope is going to be -3/2 because I have to change the sign and flip the fraction. And I'm simply going to use that point to plug in and then solve it for y. Now let's write the equation of a line that models some real data. So here is some data that's given that has the cost for the cost y for a call of x minutes. So let's let the x equal the cost per minute. And I know the flat fee is my y-intercept. The charge of 10 cents per minute would be 0.1 times x. So when I look at this, I have a slope of 0.1 and a y-intercept of 20 cents. I can apply the same thinking to a table, and in a table, the left column is the x values and the right column is the y values. I can take this to find the percentage with x